Alright, this video we're going to talk about Section 3.1, Day 2, Law of Sines with Side-Side Angles. So in the last video we looked at angle-side angle and angle-angle-side. This time we're going to look at side-side angle. Now if we're doing this, one of three things is going to happen as far as our triangles are concerned. The first thing is we're not going to be able to get an answer. Or we might get one answer, or we might get two distinct answers, depending on the relationship between AB and the angle A. So on the screen and on your paper you see different cases of what happens. So we want to consider triangles in which we're giving the sides A and B and the angle A. And then we want to remember from the area thing that we were talking about yesterday that the height H is going to be equal to the side B times sine of A. So if A is an acute triangle and A is less than H, it's not possible to make a triangle just based on side-side angle. If A is equal to H, there's one triangle. If A is greater than B, there's one triangle. If A is between H and B, we're going to have two different triangles. If the triangle is obtuse, then if A is less than or equal to B, there's no such triangle that's going to work. If A is greater than B, there's going to be one triangle that's going to work. Now, there's a lot of stuff on the page right now, but the good news is we don't really have to have that memorized if we're willing to put in a couple of extra seconds of work to kind of figure out what's going on. So let's look at a couple of examples here. So look at this first one here. Find the remaining sides and angles for the given triangle. So they give us two sides, they give us an angle that is opposite one of the sides. Now if we look at the table we had a second ago, this is an acute triangle. We know A and B. We could figure out H would be B sine of 42, so 12 times the sine of 42 degrees. And if you are looking at it, one of the relationships is going to hold that we have an actual triangle. And we can see that because we're looking at the triangle. So all we really need to do here is just use our law of sines. If we look at what we're given 42 degrees. We are given a side length A of 22 inches. So we know one of the relationships for our law of sines is going to be 22 over sine of 42. And the first thing that we can solve for is this angle B. So we can say that's going to be equal to 12 over the sine of angle B. So we can work this out a little bit, and we can get that sine of B is going to be equal to 12 sine of 42 over 22. So multiply by the reciprocal here, multiply by sine of B out of the other side. And if we work that out, we're going to get something approximately equal to 0.365. So sine of B equals 0.365, but that's not really that helpful because I don't care what the sine of B is. I want to know what B is equal to. So if we're going to get rid of this sine, we're going to have to take the arc sine of each side. So the arc sine of sine of B is going to be equal to the arc sine of 0.365. Arc sine and sine are going to cancel each other out, so we're going to get B is approximately equal to 21.406. So now we know that this angle is 21.406. Once we know that this angle here is 21.406, we have two of the three angles. So we can say that angle C is going to be equal to, so the measure of angle C, there we go, is going to be equal to 180 minus 42 minus 21.406. So we know that C is going to be equal to approximately 116.594. So we have another angle now, so 116.594. So all we have left to solve for is side C. We could use B, side B and angle B, but like I said in the previous video, it's best if we use what they give us because we had to round for this here. So we can say that c over the sine of 116.594 is going to be equal to 22 over the sine of 42. So c is going to be equal to 22 sine of 116.594 over sine of 42, which is going to be approximately equal to 29.4, and our units are going to be in inches. So if we fall into one of those nice one triangle solutions, everything works out the same way it did before. But that's not always going to be the case. So let's look at this next example. Show why there's no such triangle with a equals 15, b equals 25, and a equals 85. So using our law of sines, we would say that 15 over sine of 85 degrees is going to be equal to 25 over sine of b degrees. And we're going to kind of do the same thing we did on the last side. So solve for sine of b. So sine of b is going to be 25 sine of 85 over 15. So that's going to be equal to approximately 1.660, so 1.66. And that's a problem, because we're saying that the sine of b has to be equal to 1.66, but we know that the biggest sine can get is 1, and the smallest sine can get is negative 1, right? Sine is going to be from negative 1 to 1, so sine can never be 1.66, so this has no triangle that would match. No triangle possible. So we've seen one triangle, we've seen no triangle, so let's look at a case where there's two triangles. Find two triangles such that A equals 12, B equals 31, and angle A equals 20.5 degrees. So if we look at that, set it up the same way we've been doing. 12 over sine of 20.5 is going to be equal to 31 over sine of B. Once again, solve for sine of B. So sine of B is going to be equal to 31 sine of 20.5 over 12, which is going to be approximately equal to 0.905. And so we know sine of B equals 0.905. Well, looking at it, this can work. Unlike the last one, this is less than 1, so we are going to be all right. Just like on that first problem, to get B by itself, we have to take the arc sine of each side. So arc sine of B equals arc sine of 0.905. So arc sine and sine are going to cancel out. B is going to be equal to, if you plug this into your calculator, we're going to get 64.8 degrees. But this says two triangles. So we have to think, all right, how am I going to get the other triangle? If we think about the unit circle, .905 is going to be, for a sine value, sine being .905, is going to be somewhere right around here, right? And we know 64 degrees, 60, almost 65, this is 90. There's another place on our unit circle, right there, that's going to have the same sine value. So how we're going to end up getting that one is we're going to take 180 degrees, and then we're going to subtract this thing, so in this case 64.8, to get the remainder of my angle here. So we can also say or B is going to be equal to 180 minus 64.8, which is going to give us 115.2. So now we can figure out angle C. So if we're doing this one, angle C is going to be 180 minus 64.8. So in that case, not just minus 64.8, sorry. And then we also have to subtract the other angle, 20.5. Right, we got to subtract the other two angles from 180. And that's going to give us 94.7. And on this side, we're going to say C is equal to 180 minus our 115.2 minus our 20.5 from angle A, and C is going to be equal to 44.3 degrees. So from here, what we would do is we would use the fact that we have A and B. Now we have all of our angles. We can use the law of sines to get side B and, or I'm sorry, side C. It's the only thing we have left over. But I want to kind of go back to that first example, because on this one we found arc sine of B, arc sine of 0.905, got 64.8, and then we said, well, we could also use 180 minus 64.8, or this 115.2, and get another triangle. And we didn't do that on the first example. So let's kind of go back to that first example and show why we didn't do that. So if we look back here, when we went through and we got sine of B equals 0.365, so arc sine of B, so we got B is equal to 21.406 degrees. If we were to try to find that other angle that could possibly work, we would have to say, well, B could also equal 180 minus that 21.406. So B could also potentially be 158.594. But the problem comes from trying to find angle C. So if we try to find angle C using this angle B, angle C is going to be equal to 180 minus 158.594 minus our angle A of 42. And that's going to give us a negative number. So if we do 180 minus 158.594 minus 42, it's going to end up that C is going to have to be negative 0.2 or negative 0.594 degrees. And that's not possible. So when I was saying earlier, we don't have to have that entire thing memorized where we have every possible way to get 1, 0, or 2 triangles. This is what I'm talking about, putting in the extra little bit of work. If you check the other possible angle for B, then we're going to tell, okay, was it only the one triangle or are 2 triangles going to work? So that's going to do it for this video. We will see you in the next one.